ओ लेवल केमिस्ट्री। स्टेट्स ऑफ मैटर स्टार्ट किया था ना?
Yes, sir.
ये सब कुछ हमने स्टार्ट कर लिया था और खत्म भी कर लिया था मेरे ख्याल में ना।
Yes, sir.
तो ये स्टेट्स ऑफ मैटर है। बताइए अगला चैप्टर कौन सा स्टार्ट करना है? तरतीब से कहा था ना हमने, तरतीब से करेंगे। नहीं, इसके पास पेपर करने चाहिए।
हाँ जी सर।
स्टेट्स ऑफ मैटर के पास पेपर करने चाहिए अभी। स्टेट्स ऑफ मैटर के पास पेपर करने चाहिए, ठीक है। तो स्टेट्स ऑफ मैटर पास्ट पेपर। पास्ट पेपर। चलिए, पास्ट पेपर स्टेट्स ऑफ मैटर। पास्ट पेपर स्टेट्स ऑफ मैटर। स्टेट्स ऑफ मैटर। फर्स्ट क्वेश्चन, जून 2012 पेपर 3, क्वेश्चन नंबर 1। नाउ जून 2012 समर थ्री वन क्वेश्चन नंबर 1। क्वेश्चन नंबर 1, स्टेट्स ऑफ मैटर। चले भाई, लेट्स स्टार्ट। द डायग्राम below show part of the water cycle. State the name of the each of the following changes of state. Boले, what is the change of the state?
Sir, first one is evaporation.
Liquid to gas is evaporation, correct? It is evaporation. Now question number 2. gas convert into liquid?
Condensation.
Condensation.
Condensation. Now, which one of the above changes of state is exothermic? Yes, which one is exothermic?
Sir, the H2O gas into H2O liquid.
Sir, condensation is
Sir,
exothermic.
sir, condensation.
Condensation is exothermic, right? So now listen to my question. Which one is more energetic, liquid or gas?
Gas.
So gas is more energetic. So energy is released. Energy is released and particle come closer and become liquefied. So condensation. Can you explain why condensation is exothermic?
Sir, because it's giving out heat to because it's losing energy from gas to liquid. It's losing energy, so meaning it's giving out heat instead of taking it. So basically that means it's exothermic. The heat energy is being out. It's being sent out.
Your first part is correct, condensation, right? Because condensation. Because heat is given out. Heat is given out. Heat is given out. Which convert which convert
Gas into liquid.
gas into liquid.
So isn't it the same thing I said?
Sorry?
Isn't this the same thing I said?
Reverse of evaporation. It is the reverse of evaporation.
Okay, sir.
Now next question. Next question. Next question. June 2012. Paper 32. Question number 1. Question number 1. Question number 1. Part C. Part C. Yes, when liquid nitrogen boils, the following changes occur. The boiling point of nitrogen is very low, even though the bond between the atom in a nitrogen molecule is very strong. Suggest an explanation. बोले कौन सा आंसर होगा बेटे?
So, like, sir, what do we have to explain? Like the statement.
When liquid nitrogen boils, the following changes occur. The boiling point of nitrogen is very low, even though the bond between the atom in a nitrogen is very strong. Can you give the answer?
Sir, I think is it because it's a covalent bond?
Boiling point of nitrogen is very low, even though the bond between atom and nitrogen molecule is very strong. It has nitrogen triple bond. That's why
Sir,
it is very
sir,
strong.
sir, I got it. Sir, is it like
Yes.
because it's a diatomic molecule? So because it's a diatomic molecule, it's like there's no other. It can't be like reactive with other elements or molecules.
Now listen. The boiling point depends on intermolecular force of attraction, right? So let's suppose this is nitrogen molecule and this is another nitrogen molecule. So each nitrogen molecule has intermolecular force of attraction. This is called intermolecular force. So intermolecular force between two nitrogen molecule is very low, very weak. So less amount of energy is required to break the bond. Are you getting my point?
Sir, so wait, so is the intermolecular force high or low? Strong or weak?
Intermolecular force is very weak. That's why low temperature is required.
So tell me, how is the bonds between the atoms strong?
Beta, the boiling point of nitrogen is very low. If the boiling point is low, it means weak intermolecular force of attraction, right? Right. So now listen, first point. Weak,
Wait, sir.
yes.
But in the question it says the bonds between the atoms of nitrogen is very strong.
The bond between the nitrogen is a strong triple bond, but boiling point depend on intermolecular force of attraction, which is very low.
So what
Intermolecular means
depends on
between
bond?
the molecule. Yes,
So what depends on bond between atoms?
beta.
Between the atoms.
Between the atom, you have always covalent bond, right? Which is always strong.
Okay.
Boiling point does not depend on a strong bond. Boiling point depends on intermolecular forces. Boiling point depends on intermolecular forces. So intermolecular force between nitrogen is very weak. So weak intermolecular forces between nitrogen atoms, nitrogen molecule. First point, weak intermolecular force of attraction between nitrogen molecule. Point number 2, covalent bond between nitrogen atoms is very strong. It will not break. It will not break. Now look at the structure again. This is nitrogen. This is a strong covalent bond. This is strong covalent bond. Now look at the bonding between these two molecule. This is interaction. This is intermolecular force. and this is covalent bond. Now listen, when you heat, now you heat. So when you heat, this bond is broken and this bond is broken. Only covalent bond exists. It means intermolecular is weak, covalent is strong. That's why low boiling point. A strong bond between nitrogen and nitrogen. बोलो समझ आया कि नहीं आया?
Sir, so basically the weak intermolecular forces are there are weak intermolecular forces between the nitrogen molecules, and boiling point is like basically it's based on how strong the intermolecular force is, and then
Yes.
but the
Boiling
covalent bond
point.
is
Exactly. Boiling point depends on intermolecular forces, not on covalent bond, not on ionic bond. So if you have strong intermolecular force of attraction, it means you have high boiling point. If you have weak intermolecular force of attraction, it means you have low boiling point. Number one. Number two, why the bond is not broken? Because nitrogen has triple covalent bond and covalent bond is strong enough.
sir, but if it has like triple covalent bond, then why isn't it like not N3? Why is it N2?
Because the bond means the connection, while number of atom is different thing. N3 means you have 3 atoms. Lines
So
indicates connectivity. So triple bond means 3 electrons are shared, not 3 atom, right?
Sir, are they in pairs?
Yes, we have a lot of nitrogen molecule. All are bonded with weak intermolecular force of attraction. So they are molecule. So when you heat, intermolecular force of attraction overcome, and nitrogen gas is evaporated.
So before it
Next,
is heated, the intermolecular force is weak.
whenever you boil and it has low boiling point, it means you have weak intermolecular force of attraction. Now question number 3. October, November 2012, paper 32, question number 2. Yes, this is question number 2. This is cooling curve or heating curve? Yes, this is cooling curve or heating curve?
Heating
sir,
curve.
this is heating.
This is heating curve because it is in upward direction. Because it is in upward direction. Now this is question number 2. The diagram shows, yes, the diagram shows heating curve for a sample of complex compound X. Is X a solid, a liquid, or a gas at room temperature 20 degrees centigrade? Yes.
Sir, liquid.
Sir,
Yes, it is liquid, solid or gas?
Sir, liquid.
liquid, sir.
Liquid. Why?
Sir, because in at B, we know that at B, at the first horizontal line, B is the melting point. So it means at from B to C, the like from A to B is solid, and B from after B to C, then the C to D is going to be liquid.
Now listen. This is 20. Let's suppose this is 20. So this is solid. This is liquid. And this one is gas. So your answer is solid or liquid?
Sir, liquid.
Liquid, correct. Now B part, write an equation for the equilibrium which exists in region B and C.
Yes, sir. Sir, for this one, sir, like because we know that the first the first horizontal line is the BTC. The BC is the melting point. So it means after the melting point, it's going to be the solid is going to change into liquid. So thus CD is region CD. Region CD is liquid. At 20 degrees Celsius is liquid at BC.
It means X is liquid, B and C. Liquid or solid?
Solid.
Solid, shabash. So it's solid and solid convert into gas. Gas or liquid?
Liquid.
Liquid. So this is solid liquid. BC is solid liquid. Now C part, name the change of state which occurs in region DE.
Sir, no change
No,
because it's the boiling point.
it's boiling point, right? Good. So it's boiling. This
Sir,
is
but what
boiling.
change? It's still a liquid.
This
In
is
CD it
boiling.
was liquid and also in DU.
Now BC is boiling, right? BC boiling, BC melting.
Yes, sir. Sir, but I'm saying like CD was liquid, and in DE also it's like basically it's liquid here.
Yes,
It's the same thing. It's the
C.
same. It's in the same state.
Now read the question. Bete, carefully read the question. In the question, name the change of state which occurs in DE. Name the change of state which occurs
Oh,
in
okay.
DE.
So it's
DE.
boiling.
So name the change of state which occurs. So it's boiling. It's boiling. Now D part, explain how the curve shows that a pure sample of compound X was used.
Sir, it's because there was a fixed temperature of melting and
Fixed
boiling point.
temperature. Very good, very good, very good. So explain how the curve shows that a pure sample of compound X was used. If compound X is pure, it means it melts, it boils at a specific temperature. So if X is pure, it means it has a specific boiling point and a specific melting point. Any question regarding this question?
No, sir.
Okay,
No, sir.
next question. Two 2012 October, November, variant 33, question number 3. Question number 3. Question number 3. Question number 3. Question number 1. Question number 3, sorry. Yes, read the question. Yes.
Sir, so basically, in the container, diffusion happens where the particles move randomly from high concentration to area of low concentration, and the particles collide with each other and move away from each
Mm-hmm.
other and occupying the whole container.
Mm-hmm.
So
So
done.
now you can see that this question is for 3 marks, right? Why
So I give
after
3
about
points.
an hour, the bromine molecule have spread uniformly to occupy the whole container, right? Initially, they are starting to escape, right? And then after an hour, the whole container has bromine. So it's liquid to gas, right?
The liquid evaporates into a gas.
Hmm.
The kinetic energy between the particles increases, and the
Increases.
gas particles move faster and occupy the whole container.
Very good, very good, very good. So it means you have, and they all move in all direction. So it means you have 3 points, right? Now, first point. Liquid bromine molecule have more energy to escape from liquid to gas. Liquid to gas. This is for 1 mark. For second mark, molecule move from higher concentration to low concentration. Particles move or diffuse from higher concentration to lower. from higher to lower concentration. Now, point number 3. Particles move. Particles move in all direction. Particles move in all direction. Particles move in all direction. Yes, any question regarding this part?
Sir, for the
Yes.
first point, could you say like liquid booming evaporates to form liquid gas?
Yes, because why evaporate? According to kinetic
Sir,
molecular theory,
because
gas
because
particles
it
absorb energy.
okay.
They absorb
So
energy.
we
Either
have to include that point.
yes, they absorb energy either from the surrounding and convert into gas.
Okay.
Okay, can I move to another?
Yes.
This is B part. This is diagram number 3. This is diagram number 3. This is the question. चलिए भाई. देखिए डायग्राम 1, डायग्राम 2, डायग्राम 3. अब डायग्राम 1 में क्या हुआ गौर से सुने. यहाँ you have two limbs, right limb, left limb. In the right limb you have colored liquid. Both have same level. Here you have porous pot and here you have air. Here you have air and here you have air. So gas particles move in and out easily. But here the level is same. In diagram number 2, you have porous pot, but here you have hydrogen gas. And then in this speaker you have air. In the diagram 3, you have large beaker and you have carbon dioxide. Then you have higher level here, here you have lower level. Complete the following explanation. Diagram 1 has been done for you. Diagram 1 is done for you. Why they have same level? There is air inside and outside the porous pot. So the rate of diffusion of air into the pot is the same as the rate of diffusion of air out of the pot. The pressure inside and outside the pot is the same. So colored liquid is at the same level on each side of the tube. देखिए चेक करें.
There is air inside the pot, but hydrogen outside the pot. Hydrogen has
Yes.
lower mass than air, so it diffuses faster.
So it's because small particles are going to hit the air, the colored liquid. So it means pressure will also increase. So that's why the water levels will rise from the right limb, from the right side.
Correct, correct, correct. Diagram number 2.
So didn't we
Diagram
do
number
diagram
2.
2?
Here you have diagram number 2. Now listen. Air is more denser.
Yes, sir.
Here air is more denser. Hydrogen less denser. So hydrogen diffuses faster. Hydrogen diffuses faster. Faster than air. So it could exert more pressure. That's why level increases on the right limb. Are you getting this point or not?
Yes, sir.
So air is more denser. Than hydrogen gas. Hydrogen diffuses faster than air. Pressure inside pot is greater than outside the pot. So air diffuses more. So the air diffuses more than carbon dioxide. Are you getting this point or not?
Yes, sir.
Now diagram number 3. Yes. Yes, what is the answer in diagram 3?
Wait, sir, for the diagram 3, where was the original level? What was the original level?
This is the original level.
So why does it have many tubes, more tubes? The length of tube is different.
Now listen. This limb is higher level. So it means this pressure is more.
Wait, sir, can I say? So because the carbon dioxide is like is denser than air, so that's why air diffuses faster. So pressure, so that's why because diffusion happens faster at the right side. So it
Very
means
good. Here,
pressure. So
air
pressure will
diffuses
increase.
faster. Your first point is air diffuses faster. So air diffuses faster. If air diffuses faster than carbon dioxide, here we have carbon dioxide. So air diffuses faster than carbon dioxide. So diffusion out is faster. Air diffuses more faster. बात समझ आ रही है? यहां से भी एयर आएगी.
Sir, what if you only say like the air would like about we talk about the air on the right side, like air, so it diffuses faster.
Now listen. Here you have two sides, right? This side and this side. So here carbon dioxide enter and create the pressure. So this limb rises up. But here you have air pressure. So air pressure is more than carbon dioxide pressure.
Okay, so that's why it then it rises higher on the left side.
So inside you have more pressure.
And also the pressure is coming from the right side, yeah.
Yes. That's why it's moves up. So answer is air diffuses more than carbon dioxide. Next point, diffusion out. Diffusion out is faster than other gases. Other gases. Third point, inside pressure is less than spotless outside. Just beta, any question?
No, sir.
Alhamdulillah. Now next question is, (2014) May June variant 31. Question number 3. June 2014. June 31. What is meant by the term diffusion? Yes, what is meant by the term diffusion?
Sir, diffusion is the movement of particles, the net movement of particles from an area of high concentration to an area of low concentration, down the concentration gradient.
So, June 2014, paper 3-1. Question number 3. Yes, this is the question. Now 2014, May, June, variant 31. Yes, what is meant by the term diffusion?
Diffusion is the movement of particles from a region of higher concentration to a region of lower
Eh.
concentration, down the concentration gradient until equilibrium is
क्या बात है माशाल्लाह माशाल्लाह माशाल्लाह. What property of a gas molecule affect the speed at which it diffuses?
its mass.
Okay.
Molecular.
Now can anyone define the diffusion?
Sir, diffusion.
Guess what is diffusion?
Sir, diffusion is the net movement of particles from an area of high concentration to an area of low concentration down the concentration gradient.
Okay. So first answer is, what is meant by the term diffusion? Particles have more energy, move faster. Particles have more energy, move faster, collide rapidly, give more successful collision. This is diffusion. Atom or molecule, right? So particles have more energy, move faster, collide rapidly, give more successful collision. This is called the diffusion. Now next part, which property of a gas molecule affect the speed at which it diffuses?
Sir, it's molecular mass.
Molecular mass.
Yes, sir. No, sorry, it's, yeah, so it's mass. So the lighter the molecule, the faster it diffuses. So the property would be
Yes.
like
Can you repeat your statement of diffusion?
so mine. So
Yes,
mine was
anyone.
like the diffusion is the net movement of particles from an area of higher concentration to lower concentration down the concentration gradient.
Yes, then diffusion means movement of particles
Yes, sir. I said net movement of particles.
from the region of high concentration to low concentration, right?
Lower concentration, yeah. Down the concentration gradient.
Exactly. Movement of particle movement of particle from the region of high concentration to low concentration. Yes. What property of gas molecules affect the speed at which it diffuses? Yes.
Yes, sir, molecular mass.
Molecular mass or mass?
Sir, mass.
Mass
Sir,
or
no, sir. Be mass, sir, molecular mass because this gas molecule. So it could also be molecular mass.
yes, molecular mass. Now the B part. Yes, anyone B part. Why does the air on the other side of the barrier contain more helium? Which one is lighter, helium particle or air?
Because the air present on the other side of the barrier had a higher temperature, so it diffused when the other side of the barrier, and more helium is now.
So the correct answer is, why does the air on the other side of the barrier contain more helium?
Sir, it is because helium is lighter, yeah. That's it.
Helium is
Helium is
helium is
lighter,
lighter.
so it diffuses faster.
Yes, yes. Helium is lighter. Very good, mashallah. Then molecules in the air. Helium is lighter than molecules in the air. So helium diffuses faster than air. Helium move faster than air. Next, what is it an advantage to have the air at a constant temperature?
It diffuses
Sir, it is
faster
because
Why faster?
because the temperature is high.
because the temperature is high, so the energy, so the particles gain more energy and move faster. So diffusion happens faster as particles collide with each other more.
Faster rate of diffusion. Faster rate of diffusion at high temperature. Yes, any question?
No, sir.
Okay, next. C part suggest so B second and then C second. Yes, suggest another method other than diffusion by which helium could be separated from the mixture of gases in natural gas.
Sir, electrolysis.
Sorry?
Sir, electrolysis.
Okay, then yes. Yes, beta.
Yes, sir. Sir, because because air is a mixture, so could we like use a filtration method?
Okay, then.
So then what?
Now listen again. State another method other than the diffusion by which helium could be separated from the mixture of gases in natural gas. Fractional distillation. Fractional distillation is a technique to separate some gases from a mixture. For example, nitrogen can be separated from the air because air is a mixture. Next, June 2014, 33. So suggest mm, so next question is from June 2014, paper 33, question number 2. The rate of most reactions increases at high temperature. June 2014, variant 33, question number 2. Yes. G answer.
Oh, sir, my mic was muted, sir. Sir, I was saying it is because when particles gain heat, they gain energy, and so
Mhm.
they move faster and collide with each other more frequently, and move away from each other by colliding, thus increasing rate of diffusion.
Very good.
Wait, this was thus increasing rate of reaction.
Which increases the rate of reaction. Very good. The rate of most reaction increases at high temperature. So when you increase the temperature, velocity of the molecule increases, they collide rapidly. So first point, particles have more energy, move faster, they collide more frequently, more particles have energy greater than energy of activation. Any confusion? Yes, any question?
No, sir.
Whenever you increase the temperature, velocity of the gas particle increases, their collision increases, right? Their collision increases. It's their energy is greater than energy of activation.
Okay, sir.
Saad and Umar, are you
Yes, sir.
Yes, sir.
are you both of you are ready for the test?
Sir, for which topic?
Moles.
Moles.
Yes. Now you have all of you have 10 minutes for the revision, right? Then I am sending you the moles question on your WhatsApp group, and you have maximum 1 hour to solve all the question and return back to my WhatsApp number, right? Saad, are you ready for the test?
Okay, sir. So it's like only moles here, like conversion.
Yes, moles and other conversion, right?
Okay.
So basically you have 10 minutes, right? Now you have 10 minutes, right? After 10 minutes, I am sending moles question on your WhatsApp number, right?
Sir,
Yes.
can you upload last week's recordings?
Yes, I am sending. Inshallah, I will after the end of today class or by tomorrow. I will share all recording of O level, right? In your
Okay.
respective group, right? WhatsApp group.
Okay.
Sir,
Yes, you have 10 minutes
is
to revise all.
sir, is net ionic equation also there?
Yes, any question. It's mixture, right? Okay. I am just ending the class and be ready. After the 5 minute, I will upload a new test, right? Of bonding. Okay.
Okay,
Take care.
sir.
Allah Hafiz.
Love. Thank
Allah
you, sir.
Hafiz.
Allah Hafiz.
Your duration is 1 hour.